Hello everyone, this is Jeff from the Ozark Mountains in Missouri, USA. Today, we're going to set about getting a better picture out of this old A500 by using one of these, an Extron video scaler. You might remember, a month or so ago, when I took this A500 out of the box, I used the included A520 composite adapter to get it up and running more quickly, but the picture, while okay, wasn't all that great. These Extrons are a commercial video scaler that are kind of old technology now as far as video production companies and TV studios and such are concerned, but they're great for our retro gear. So today we'll take a look at making a cable to connect the Amiga to the Extron and get VGA output. Before we get started, let me remind you about the contest. At some point in this video, I'll imitate one of my favorite YouTubers, some mannerism or saying that they are known for, and the first person to guess who I'm imitating and what I'm doing to imitate them will win a prize. Things up for grab include a Commodore 64 case saver kit, a couple of square 5-pin Amiga or C128 power connectors, that type of thing. You might be saying to yourself, "Hey Bert, what the Sam heck is a video scaler, and why do I need one of those to connect my Amiga to a VGA display?" Well, that's a darn good question. I'm glad you asked. A scaler is a device that takes video in one format and alters it to fit a different type of display. Older video formats were not only lower resolution, that is, there was less pixels on the screen, but they also had a different output frequency. Modern displays use a higher frequency, which is needed to get more pixels on the screen. Let's have a look at that and see if we can't figure out why. Way back in the old days, when computers were still steam-powered and we had to ride our dinosaurs to school, monitors and TVs were made with cathode ray tubes, or a CRT. A CRT is a big glass tube that has a phosphor coating on the front. Well, the inside of the front, to be more precise. An electron gun at the rear shoots a stream of electrons at the phosphor, which causes the phosphor to glow briefly. The stream of electrons is steered by the means of electromagnets and is turned on and off at varying intensities to make the phosphor glow more or less bright at the correct locations. The electron gun scans one horizontal line at a time. It'll scan across and turn off, come back to the start of the next line, scan, turn off, etc. until each line is done. Then it shuts off, goes back to the top of the screen, and starts over. The Amiga uses a horizontal scanning frequency of 15 kHz, which is the same as TVs at the time used. A VGA monitor, on the other hand, uses a frequency of 31.5 kHz, which allows it to display a higher resolution image. But why is that? Well, let's take a look at my CRT on paper here, and we'll just use some nice round numbers, whereas on a normal display you'd want something like 60 frames per second. We'll just go with a nice round 1 frames per second. And we've got 10 scan lines marked out here on the paper. Forgive the fact that they're not evenly spaced, we'll just ignore that. So if we want to scan all 10 lines in 1 second, that means we have to go across and back. We have to have one complete path, scan across the screen and back in 1/10 of a second. So we have 10 lines across and back in 1 second, means each line will take 1/10 of a second. Now what happens if we double the vertical resolution of the screen? We have twice as many lines in here like this. Well, we still only have 1 second to get this whole thing drawn, so now we're going to have to do 20 lines in 1 second, which means that each line, each trip across and back, can only take 1/20th of a second. So we're going to have to scan twice as fast horizontally across the screen to do that higher resolution. This is very similar to the difference between the Amiga's video output at 15 kilohertz and a VGA's scan frequency of 31.5 kilohertz. Not only does a scaler like the Extron unit have to put up with this difference in horizontal scan frequencies, but the effective dots per inch of the incoming signal is different than the effective dots per inch of the outgoing signal, so it has to transform one to the other and do so in a way where you minimize the loss of any data or artifacting, which is not an easy task. And because these Extron units were made for commercial applications such as video production places and TV studios and whatnot, they are pretty top-notch units and they do a really good job. The great thing now is you can go on eBay and find one of these for $50 or less. And it makes an excellent scaler for our old computer gear. Well, now that we have a little bit of an idea of what a scaler is and why we need one, we need to get on to making the video cable. And there's one big kink in that plan with the Amiga, and that is the fact that for a video connector, they use this guy. And while at first glance that looks like a pretty standard D-sub connector, it's a 23-pin connector, which is an odd size. You have your normal 25-pin connectors, but they don't quite fit. The 23-pin D-sub connectors are something that Commodore had made up so they could use a special sized connector for the video as well as the external disk interface and not have it be confused with the other 25-pin connectors on the back of the machine. Now why this worked out great, them being a non-standard connector, means that, well, they're no longer available today. Nobody's making any new ones. There's some folks that found some new old stock that they used to make their own cables and adapters, which is great. And it's also possible to modify a standard 25-pin connector to do the job, which is what we'll be taking a look at today. Let's run out to the shop and see how that's done. I mentioned that we're going to be making a 23-pin D-sub connector, and that's not quite right. What we're going to do is modify a 25-pin D-sub connector, which is a standard unit. The 23-pin unit that Commodore used for the video output and the disk drive were modifications of this, and they are no longer available. In the mill, we've got a block of plastic that we're going to machine into a fixture to hold the connector securely while we're machining off the one side. Let's get started. First thing we'll do here is indicate to the rearmost left corner of the stock, and we'll set this as our 0, 0. The tool we're using here is called a wiggler. When it touches the part, you'll see it kick out ever so slightly. That's how we know that we've touched the part. The next thing we'll do is drill a series of small holes that will later tap to hold the 25-pin connector down to the stock. Now you can hear the compressed air that I've turned on to blow the plastic chips away from the drill bit and to keep it cool. Here I'm using a 1/8 inch O-flute carbide end mill to cut a pocket in the plastic block that the DB25 connector will set down in. Here I'm test fitting a connector and finding out that the pocket is indeed slightly too small, so we'll make it just a little bigger. The pocket was enlarged slightly, and we'll test our connector again, and this time it fits great. Next thing we'll do is tap the 4 small holes that hold the connector in place while we're machining the end of it. With the holes tapped, we can screw the connector down onto the fixture. Now I'll put a little water-based cutting fluid onto the part and we'll start the machine. And this first move here where it takes a chunk off, that was a mistake in the G-code. But you can see now it'll come in, it'll take small passes off the end of the DB25 to give us a DB23. And here is what the rest of the cut looks like, speeded up about 400%. Here is what the result looks like. Now this looks a little raggedy because we cut through where two of the pins originally were, but it is actually a really good fit. Here are the 3 cut down DB25s I made turned into DB23s. This is my initial one. It was a used connector. And this actually turned out pretty well. And I thought, well, you know, I'm not actually cutting much off of there. I can just do that in one pass and I come back with a finished pass. But of course this turned out awful because as it's coming around there, it has a tendency to want to peel up that bit of sheet metal. So this one's not usable. This one is fine now. As you might be able to tell by the fact I have wire soldered onto here. This one came out fine. This was just another modification of the toolpath, and I realized once I got to wanting to solder this up that I should have trimmed off this edge of the connector, because on the female that connector, pin 1 is on this corner. And I'm soldering up some small lengths of some 75 ohm coax cable, which I cut out of the middle of an old video cable. And that is going to connect to one of these DB15 high density breakout boards, which are made for VGA. They very nicely took the pins you need for like red color and red ground and green color and green ground, etc. And they put these all on one side, which makes it really nice. So I've got these cables already prepared and they'll go in there. And then I can just use a regular VGA cable up to my Extron video scaler, and I'll have another one of these up there to break it out to go to plugs like this to plug into the Extron. And eventually I might make up some with BNC cables, so I'll have to use a BNC to RC adapter on the Extron end. But this will give me some freedom to experiment, make sure I've got the wiring right. You can actually buy these adapters that go from the Amiga DB23 to DB9 and the VGA pinout. And those will even have a buffer chip included for the sync signals. And those are fairly inexpensive. That's probably the way to go. I just wanted to experiment. And once I get this working with the RGB, then I'll go back and try to get the digital RGB working as well, and maybe use that on a 128 monitor just to see how that works. The construction of the cable is done now. Let's have a closer look and see how that was made. The part that you see right here from the chrome connector to the black box is the actual adapter cable, and of course this is just a normal VGA cable. Oops, dropped that out of there, didn't I? Here's the adapter all wired up. All the video signals used 75 ohm coax cable, which I cut, as I mentioned before, from an old video cable, and I saved both ends, as those might be useful later. And the 3 wires for the sync, which turned out to be 2 wires for the sync since I only used a composite, and the ground were done in a normal 2 wire with shield cable. Here's the trimmed down DB25 into a DB23, and you can see it looks a little funny because of the missing pins and the fact that this is silver. When you see pictures of these online, they always show them at an angle like this, so you can't really tell it's cut off. But you'll see them say if it's a real DB23 one that's not been modified, they usually point that out in the ad. I think if I wanted to make a really nice looking one of these, what I would do is drill out this part of those 2 pins I was going to machine off and fill the remaining holes with a black epoxy, let that cure, and then machine off the end. Originally I had planned on using this adapter cable to go from VGA to individual plugs for red, green, and blue, horizontal and vertical sync. And then I realized that the T-sub-15 connector input that was on the Extron was actually wired up just like a VGA plug, so I didn't need to do that. Let's take a look at the Extron now. This is the Extron DVS-304. This has 4 inputs, and they can be different types of inputs, and your menu navigation buttons and a little LCD screen to see what's going on. The business end of it looks like this. Now this particular one has an S-video. These can be used as component inputs. This is composite. This is the RGB in for like what we're using on the Amiga. And this is the output section. You can output individual RGB with the sync or DVI. I found out that this DVI version does not work with the non-interlaced video of the Commodore 64. There's a DVS-304 that has a VGA output, which is what I have hooked up right now, and it does work both with the Amiga and with the Commodore 64. And there's also a wider version that does audio switching in addition to the video switching. And over here you see an Ethernet connection and a serial connection. These are set up so you can actually remotely control these through a serial link from a computer or an Ethernet link. You can actually go in over the Ethernet link and update the firmware and change the settings and things like that. It's a pretty neat little unit. There is no on and off switch, so I have a power strip set up to power the monitor and the scaler and everything all at one time. Now that we've taken a look at how the cable was built and the Extron scaler itself, let's do some head-to-head comparisons between the composite output and the RGB output from the Amiga 500. That involves a program called Test Card, and I'll put a link to that down below, as well as an external Gotek unit, which is the subject of an upcoming video, along with some more restorating and future-proofing. So, yeah, let's take a look. Test Card was designed to aid in troubleshooting and adjusting CRT monitors. Here is the workbench. On the left is the RGB output, and on the right is the composite output. And notice how kind of muddy and slightly blurrier the right looks. Here is the test card entry screen, which is a good indication of how text looks. You notice that on the left, the RGB output is nice and crisp and the red shows up good against the background, whereas on the right, the text is much blurrier and the red is very difficult to see. Here we have a typical test pattern, the left being the RGB output, right being composite. And notice that on the RGB output we have gray grays, whereas on the composite they're more brownish. And of course the RGB output is also much clearer with much purer colors. This is a checkerboard pattern. On the left is the RGB output, and this really gives you a good indication of how much brighter and whiter the whites are with the RGB output. The composite output, they have a slightly brown hue to them, and of course the edges are a little blurrier. This is a gradient pattern where it gets finer as it goes down the screen. You notice in the composite output on the right how the last two sections blur into solid colors rather than the gradient lines. Here we have a color bar test pattern with the RGB output on the bottom. You notice how the RGB colors are brighter, the transition between colors is much sharper, and the composite output, the colors just look kind of muddy and not well defined. Here's a comparison of the grayscale output. The bottom is the RGB output, and notice how we have true grays and a good transition between colors, and the top is the composite output, and they're more brown and slightly muddier, and the transitions aren't as nice. I really like these Extron video scalers. They're quite a bargain on places like eBay. One thing I did notice is that the DVS-304 that has the RGB output has a feature called pass-through. When it sees what looks like a normal VGA signal coming in on the DB15 plug, it'll just pass that through, which might be convenient if you had a computer with a typical VGA output. You could connect to that input on the Extron, and when you switch to it, it would just pass the signal straight through without any scaling. In the case of our Amiga, that doesn't work so well. To get around that, instead of using the separate horizontal and vertical sync inputs, I use the composite sync. And in this mode, the Extron doesn't see that as a typical VGA signal, and it will scale it and process it and output it properly. On the Extron DVS-304 that has the DVI output, it doesn't have this pass-through feature, so you shouldn't have that problem, but these don't work with a non-interlaced signal from a Commodore 64, and I think there's a few old game systems that have the same type of output signal. I find that the DVS-304 with the VGA output works well with everything I've tested so far. I hope you've enjoyed this look at getting the Amiga 500 set up with an Extron video scaler. Learning how to machine down a DB25 to make a 23-pin D-sub connector and building the adapter cable was a lot of fun. As I mentioned before, there are ready-made adapters for this, which would greatly simplify the process, and some of those also use a genuine 23-pin D-sub connector, and they're not very expensive. I went this route because I also want to investigate the digital RGB output of the Amiga at some point in the future. The digital RGB output is similar to the output of the Commodore 128, so it should be interesting to see how that compares with the analog RGB output that we're using right now. If you're a subscriber, thanks, I really appreciate it. It's very encouraging to see the number of subscribers growing. If you're not a subscriber, what are you waiting for? If you look down below, you'll see a rectangular subscribe button. Just click on that dude, and it'll let you subscribe. Once you subscribe, you'll see a bell-shaped icon, and if you click on that guy, it'll let you know just as soon as I post a new video. If you would like to help and support the channel, I've recently set up a Subscribestar account. The link is down below. This money goes right into procuring computers and equipment for making videos. Some future videos that are coming up include setting up a Gotek unit with flash floppy. I showed you the start of that today. As well as we'll get back into the work slate and give that cassette mechanism one more shot at getting it working. If you have any questions or comments, please leave them down below. I'd love to hear from you. And until next time, bye.